Today we will learn how to use this multimeter. We have different variety of multimeters available in the market for various functions. This multimeter is a basic level multimeter. All the basic level functions are available here. Now we shall learn how to use this multimeter for checking the electrical circuits and their components. This is the display of the multimeter. And we have two probes, red probe and the black probe. Red one is the positive probe, a black or common one is the negative probe. And we have a selector switch by which we can measure various electrical variables and their functions by rotating the switch. By this multimeter, we can learn DC voltage, AC voltage and DC current. While checking the DC current, the red probe has to be connected to the ampere connector. Also, we can measure diode and the wiring continuity. While checking the DC current, we have to move the red probe to the ampere side. For checking the diodes, we have to set the selector switch should be moved to the diode position, and also for checking the resistance, the selector switch should move to the ohms position. To measure the DC voltage, first we have to select the DC voltage symbol in the multimeter, and also we have to select the range of the voltage which is need to be checked. The range in the multimeter is given from 200 millivolt to 1000 voltage. And red probe has to be connected to the positive terminal of the electrical circuit, and common probe has to be connected to the negative terminal of the electrical circuit. As in this case we are using 12 volt transformer, we will be selecting 20 volt in the selection because 12 volt is lying between 200 millivolt to 20 volt. While checking the voltage of the battery, please keep in mind the circuit should be in the closed condition and ignition should be on. Similarly, for checking the battery, the red probe has to be connected to the positive terminal of the battery. The black probe has to be connected to the negative terminal of the battery. And selector switch should be in the DC voltage position. You will have the voltage displayed on the screen. The voltage of the battery is displayed on the screen. Suppose by swapping the terminals red to the negative terminal and black to the positive terminal, the voltage displayed on the screen will be in the negative as the polarity is reversed. So this is how you have to check the voltage of the battery. For checking the AC voltage, select the AC voltage symbol on the multimeter and select the range. The range is from 200 millivolt to 750 volt. Always select the maximum of 750 volt AC voltage whenever you are checking the AC voltage, as the voltage supply is between 220 to 440 for the domestic and commercial supplies. So this is how you have to check the AC voltage. The red probe has to be connected to the positive terminal and the common probe has to be connected to the negative terminal. You will have the voltage displayed on the screen. In AC voltage, unlike DC voltage, even after swapping the probes, black to the positive, red to the negative, the value does not change to negative. The value will be same only. Always you will get to have the same value. Similarly, to check the DC ampere, select the ampere symbol in the multimeter. The range of the DC ampere is from 200 microampere to 10 ampere. This multimeter can measure the maximum of 10 ampere current. And the red probe has to be moved to the ampere connector. And unlike in the DC voltage where we connect the probes in parallel, here we have to connect the probes in the series. The picture shows you a very clear indication about the series connection. Let's have an example of connecting the DC motor for measuring the current. One end of the DC motor is connected to the carbon probe. Other end of the DC motor is connected to the negative terminal of the battery, and red probe is connected to the positive terminal of the battery, and the selector switch is selected for the ampere. So by having the selection to the ampere side, you will understand the current consumed by the motor, and also motor starts rotating as it is connected in series. So this is how you have to check the ampere in the multimeter. To check similarly for checking the continuity, select the continuity or diode symbol incorporated in the multimeter, and for selecting the continuity in the wire, connect the probes on the either end of the wire, and you will have a beep sound and some measured value on the screen. It shows the wire is okay. This is how you have to check the continuity of the wire in the electrical circuit. Suppose if the wire is open, wire is cut in between, you will not have the beep sound and no display on the screen, or you will have the infinity on the screen. This shows that wiring is not continuous. It has some disturbance in between. The wiring is cut in between. Similarly, for the electrical circuit board, the input to be connected to one probe, the output is connected to the other probe. You will get the beep sound. Similarly, shows the working of the PCB. That is, the PCB is good. If the PCB is short in between, if it is not continuous, you will not get the continuity, and hence you can understand the PCB is non-operational. You have to replace the PCB. So this is how you have to check the PCB. For LED, the anode of the LED is connected to the red probe, cathode is connected to the black probe. The LED starts glowing and you will have some measurement on the screen that is called the threshold voltage. Similarly, for resistance, you have to select the range, appropriate range of the resistance for the component which we need to select the resistance. Ensure that component is away from the electric field and connect both the probes on either side of the component, and you will have the appropriate resistance displayed on the screen. So this is how you have to check the resistance of the